Welcome to this video for 2023 C# Advent. My name is Barrett Blake. I'm going to be talking about some of the cool new features that are available in Entity Framework Core 8. As you know, with the latest release, there are a bunch of new features that are available in Entity Core Framework 8. Just a little bit about myself first. So I am Microsoft MVP. I currently work as an Azure Solutions Architect, as a consultant. I'm, a husband, father, a gamer, model railroader, and I'm also very involved in the community. So, speaker, blogger, mentor. I've done some part-time teaching, and hoping to get back into that a little bit more as well in the near future, if the opportunity presents itself. So that's a bit about me. So I'm just going to go ahead and jump right into the code. Let's go over here to Visual Studio. All right, that's enough of the slides. So just to demonstrate some of the stuff, some of the new features that are available in Entity Framework Core 8. There's a lot of really cool new stuff, and in fact there's far more than I can go into in even a long video, much less a short one like this. But I'm just going to highlight a couple of the things that I think are very cool and very useful as far as the new features goes. Okay, so the first thing we're going to start with is the complex type. So what we have, a lot of times in our .NET code we have classes that nest inside of classes, and if they're single instance, a lot of times, even in that case, you have to use a bunch of, custom logic in your context classes in order to save that to a database table, and reload it when you're loading it back in. But with the new complex type, what you can do is you can just inline that directly into, the nested class or the parent class. So, for instance, we've got this customer. The customer has an address. That address is represented by this object. Now, in cases where we're just going to assign a single value to that, when you're handling that in the database, you can do that funky logic. You can put it into a subtable. You can do it inline, or you can come up with different ways of saving that address information as part of a customer. But using the complex type, and use this annotation here, it's called complex type, obviously. What you can do, and when you save that to the database in your context, it will automatically inline that into the database table. So for instance, if I go over here to my context, you can see I've got my customers as my DB set, but I don't have to do anything else for it. You can ignore that. It's something I'm going to show you a little bit later. You can ignore this comment and stuff out. So you don't have to do anything else. It'll automatically inline that into the customers table. It'll create a single table, called customers, and put that information in there. The address information. I'll show you that here in the database in just a minute. But one of the things you can also do is you can nest these complex types. So here I've got geocoordinates, which represents a latitude and longitude as a pair of doubles. And that's inside the address, and the address is inside a customer. By using this complex type annotation, Entity Framework Core will handle all of that logic for you. You don't have to do anything special in your context in order to save and reload that data as part of that. So I could come down here into this class that I've got down here, and I could just say, let's start with putting in our context, and then I could do I need to see here. And we'll just say, of our address equals new address, and let it just populate some garbage data there. Oops, there we go. And then when I go in here and I say equals new customer, John Doe address. Customer, there we go. And then I can go something like that. So it populates this into my object and it saves it to the database. Let's see, and as you can see, I've neglected to put in my constructor. By the way, if you're not using Copilot, Copilot is amazing. You can see I just put that in there. It's automatically recognize, hey, you're missing your constructor. Put that in there, and boom, there it is. Same thing with my customer. I have not put in a constructor yet. And boom, there it is. Copilot takes care of all that for me, so I don't have to handle any of that myself. So I do that, I create this, and it saves it into the database. So let's go ahead and save this. Then I'm going to go over to my program. I'm going to say var. Hang on a second here. What did I call that? We got too much clutter up here at the moment. And I call this customer runner. Not repository. Customer run. No, not repository. Okay, sometimes it's a little too helpful. Okay, and cr.run. So I've gone through and I've got my customer with my inline address, and then the address has inline geocoordinates with these complex types, these two complex type classes. So if we look at our migration here that gets generated from that, you'll see what it does. You've got your core customer table columns, and then for the address one, it gives this prefix of address. So address 1, address city, address postal code, address state, and then that nested geocoordinates within the address. So you got address, geocoordinates, latitude, and longitude. So that's the way that it converts the complex classes or your complex types into your SQL table. And as you can see, as I pull up this here, you can see that it's put that stuff here in the database with that structure. So now, if I go back to my customer runner and I run this, and I save the changes. So let's go ahead and let that run through. Then I come back here to my customers table. All right, so we ran through that, and so now you can see that the record here, my John Doe, has been added to the customer table. So what about getting that information back from it? So if we were to follow this up and say, okay, var cust equals let's say default async, we'll say x goes to x dot first name equals John. So obviously you can do that, and that's your normal query. But those complex types, you can query it right into those as well. So if I do var new cust2 equals x goes to x dot address dot city. Oops. City equals any town. You can do that as well. So you can query into those complex types, as far deep as they're nested. You can just keep going deeper and deeper, and it'll generate the SQL just as it needs, however it needs to build it, and you'll get the record back. So query. You can find that querying is just as easy as anything else. So what if I want to go, really deeply nested? So let's say I want to do a more complex query. So if we go and say, okay, what if I want to, I live in Central Ohio, and the county that surrounds the city of Columbus is called Franklin County. So let's say I want to find all the customers that are within Franklin County. So if I have this query here where I've set up these coordinates, say, okay, this is kind of like the northwest corner of Franklin County. This is kind of the southeast corner of Franklin County. Find me, if I can spell Franklin, find me all the customers who live kind of within those coordinates and generate a list. You can do this kind of thing as well. So you can do, full-on queries against any of the data and any of those complex types, however deeply they're nested in there, because it's all really in the same table, and it makes it querying very easy as well. So I can do something like that. So going on from there, so the next thing I want to kind of talk about is mutability just a little bit. So let's say, I've got this this customer, and I've got, I've created one customer from this. Let's say I've got multiple customer records. So let's say I've got var, oops, sometimes it's a little too helpful. Cust2 equals new customer. I got Jane Doe, and I'm using the same address instance for all three of these customers. And I go and I add these three customers, and I save all those customers to my address database, just like that. So what that will do is, with Entity Framework, of course, it keeps track of records as you're creating them and you're working with them. And it will create those three customer records in the database. They'll all have the same address. But what if after I've saved it, then I go in here and I do something like address dot, let's say I got the street number wrong. Let's go address dot, address 1 equals 456 Main Street. And then I go in here and I do save changes. So what's going to happen in this particular circumstance? What that will do when I do the save changes is it will actually, because it's already tracking all three of those customers, cust1, cust2, cust3, it will actually update all three records in the database in this particular instance. So you have to kind of be careful when you're working with these complex types, because you're kind of meshing these concepts of your .NET instances where where all three customers are pointing at the exact same instance of address, as opposed to the way relational databases work, where those, once they're in the database, those are three separate records. Well, as far as Entity Framework is concerned, at this point, they're all three the same address record. And when you save that, it will update all three of your customer records in the database. So you have to really be careful about how you're structuring and working with these complex types in your data. So one of the things you can do, so let's say you save it and then maybe I want to come back here and load all those three records back in. Well, let's say, let's just do this, where I'm getting all the customer records back. I'm getting cust1, cust2, what was cust1, cust2, cust3. And those come back in as three separate records. And then I go in here and do, cust dot first dot address. And I change the address on the first one. What happens when I do the save now? Is that going to, again, update all three of my customer records? And the answer is no, because at this point, all three of those customer records are pointing at different instances of address. Each one has its own instance because they were loaded back in, and they're considered separate records at that point. So it can get a little confusing. You kind of have to watch, how mutability works with that kind of stuff. Now, there are a number of things that you can do to kind of work around that. You can implement these complex types as immutable. And, when you're creating them that way, once you've created that customer 1 record and your customer 2 record and your customer 3 record, you can't make any changes to that at that point. You just save them. If you wanted to make changes, you'd have to reload them back in or work with them as a new instance. So that's one way to work with it so that you don't run into this kind of situation. And there may be reasons why in the structuring of your .NET code you would want to leave that mutability in there, but you should be aware that that's something that you might run into and that might cause you problems. So that's enough on complex types. That's one of the really cool things that's in there now. So let me go ahead and do a different situation here. So let's talk next about primitive collections. So one of the things that's very common in a .NET structure, the way you build things, is I may have like a public list of GUIDs for my wish list products. So say wish list product IDs. And let's say that I've created this list of GUIDs that's tied to my customer record, which stores their current wish list of products. And that list is product IDs that are tied to some other record product that I might have somewhere else in my database. This is something that's very common in our .NET code, but when we're saving that to the database, we have to come up with some kind of different manipulation of that data in order to make that work as far as the saving and reloading the data. It might be storing that list of GUIDs as a string in your customer table, or it might be storing them as a subtable that you have a foreign key relationship to. There's a number of ways to do that, but and you have to go into your customer context and come up with some way to structure that so that it works. And that's one of the unfortunate inconsistencies between how relational databases work and the way .NET works, is that .NET obviously has this concept of arrays and lists, whereas most relational databases don't have that concept. That's not something that they can support out of the box or even have a concept of working. So we have these primitive types, like date times and strings and ints and whatever it might be, doubles and GUIDs. And we can save those very easily as part of our .NET, but we have to come up with that, like I say, way of manipulating it in order to get it in and out of the database. And it's also something that you can't do like link queries against that kind of stuff very easily, because of that manipulation to get it into and out of the database. Well, one of the things that EF Core 8 now supports is these primitive collections. Okay, so when we've added this wish list, this list of GUIDs to wish list product IDs. I was kind of getting ahead of myself. So it actually stores it as a string in the database, but it handles all that manipulation back and forth automatically for you. You don't have to do anything. Again, you don't have to do anything in your context in order to make this work. So I've saved that and I've created my migration. So if I go over here to my wish list migrations, you can see that it's adding to the customer table this nvarchar max string. And we go ahead and do our update database. And it has added to our database structure here. Let me refresh that. So if I pull this up here, you can now see under the columns, there's this wish list of nvarchar max. And if I were to go over here to my runner, and let's clear out some of this stuff here. And let's say, for cust1, let's just add a couple of random IDs here. and save the changes, and let's comment out the rest of this here. Let's move some of this stuff down. Make it a little easier to read. Oops. So we create this. We'll go ahead and run that. And let it run through. And if we come back up here to our customers table, let's just change that to stuff. Now we can see that it's added this wish list product IDs. So it handles all that stuff for you inline. So, this could be dates, it could be, like I say, any of the primitive types or any simple list or array. It'll take care of for you inline. You don't even have to add any kind of annotation to it. So you can see it's just a list in my class. I haven't done anything special. I haven't added any annotations or anything like that. It just works. And that's one of the great things about EF Core 8. So what you can also do is you can make queries against that. So if I were to come back in here and say, okay, let's say I've got a product ID. It doesn't really matter what the ID is. And I say, give me okay. So we have a a particular product ID, and then we can find any of the customers where that wish list contains that particular product ID, and we can return that as a list. So, sorry, I'm still getting used to the syntax and exactly how all this works as far as the new features go. So that's one of the ways that these primitive collections can be used with SQL Server now and with other relational databases. It's not just SQL Server; it's any of the relational databases. And what it's doing behind the scenes is it's using, for SQL Server in particular, it's using the functionality of the Open Json syntax, able to use that logic against that list of of data that's stored in that string in that field in the database. So what it'll do is it'll take that and kind of convert that into a SQL query. Again, relational databases for the most part don't have that concept of an array functionality. What this will let you do is let you pass in array values into as a parameter into the database in order to do some kind of query like that. So like so let's say birth date. Say we're tracking the birth date of our customer. So, and that's one of the other things that EF Core 8 now supports natively is date only and time only, and working with that with SQL Server and other relational databases without having to do any kind of manipulation. So let's say we've got a birth date here, and we come over here and we say, instead of that, say I want to get customers who are born on a list of certain dates. So let's say new date only. Let's just say I've got a couple random dates here, and I want to find all the customers who are born on those two particular dates. So one of the things that I could do is here, I could say contains x dot birth date. Whoops, no, yeah, I forgot it was date only nullable instead of date only. That was my problem. So But you could do it as a list too, as long as you're comparing it to a list. But you can do something like this. So you're passing in an array of values, and you say, okay, if this particular value in the database matches to anything in my list that I'm passing in, give me those results back. So you can query against that list the same way. So one of these things that these new primitive array collections let you do is pass in basically a table of data, which is something that was very difficult to implement into SQL Server or to relational databases in general up to this point. So that's something that's fairly new, or that's new in EF Core 8 as well, is being able to work with that. And again, it uses that magic of OpenJSON in the back end to convert that string variable that's stored in there into a JSON array that it can work with and deal with. And that's really where a lot of the improvements in EF Core 8 come around, is working with JSON document data and all the really cool stuff that's in there and is supported now natively. There was some support for it in EF Core 7 for these JSON columns in relational databases like SQL Server, but EF Core 8 has really ramped up that support to whole new levels, and it works really well now. And that's kind of the last major thing that I want to talk about is these JSON column enhancements. The support for JSON columns in a database. So one of the things, so let's go back over here to my customer's example. Let's say instead of a single address, just remove this reference and this reference. Okay, let's say instead of a single address, let's call this previous addresses. So let's add this new field called previous addresses. And we can leave the complex type in there. It's not going to affect this. But one of the things that we're going to do is to say, okay, now this is the current address that we stored in the customer record. Now we've got this list of previous addresses. Instead of storing that as a subtable, with foreign key relationships, which is kind of what would be the default of how we would have to work with it in the past when working with relational databases. What we can come and do is come in here into the context, and we can do this and specify that it should store that as JSON in the database. So say, okay, we're going to put this into a JSON field in the database. So go ahead and do a build. Okay, that looks good. And so we're going to add our migration. And assuming everything works out well, it's not continuing to construct it. Oh, whoops. Yeah, we can take that out for the moment. So I didn't need to remove that from there. So, well, there's that birth date I added, but it's also going to add a JSON column here. Okay, so what I've done is I've created this customer with 3 addresses, and that'll go into the previous addresses list, and I've saved that to the database. So you can see that stores that as a varchar max in JSON format. So you can see here it's got the JSON data, address 1, address 2, address 3. Well, I mean, this address 1 is the first field, but it's got all 3 addresses here stored in the data. But then the cool thing is that you can come back and you can make queries against that. So again, like I was showing you earlier, you say, so I can do cust equals, where x dot previous addresses dot any y, come on, y goes to y dot address 1 equals 123 any street typo to I not line up my close parentheses. Oh, it's first entity. It can't go to a list. Okay. So you can do something like that. Let's do customer. So you can do something like that where you are searching within that list of data, and it handles all that conversion for you. And again, it's using that magic of open JSON syntax on the SQL Server side to search into that, and it will return any of the records, or return the first record in this particular case that contains that as the address 1 field. So that's one of the coolest new things. Another one of the coolest new things that EF Core 8 has provided to us. There's a bunch of other stuff that EF Core 8 has in there now. It's got a bunch of stuff like being able to look up tracked entities. So now you can get direct access into that list of entities that Entity Framework is storing or is keeping track of. So you can do searches against those kinds of things. You can check to see if there's any pending model changes. So you can kind of do a check to see if I need to make saving changes or need to save changes to the database. You can do raw SQL queries against unmapped types now. There's a lot better syntax and performance for execute update and execute delete. There's enhancements to some of the math translations. I mentioned earlier that there's support now for date only and time only on SQL Server. And one of the coolest things is there's now full JSON support for SQLite databases. So that's something that's new. It's in there. And there's like across the board performance increases for a whole bunch of stuff and a whole bunch of different kind of queries. And there's now going to be, I don't know if it's been released yet, but if it hasn't, then very shortly they'll be releasing a native provider from MongoDB, which is something that you kind of had to work around previously. Use one of the more generic providers, but now there's a native provider from MongoDB that's out there or will be about to be out there. So there is a bunch of stuff that's out there for Entity Framework. Core 8 and the new features. There's just so much, and there's a lot of really cool stuff. And I know I kind of muddled my way through some of it just because it's all fairly new, and I'm still myself getting used to the syntax and how these different queries work. But all this stuff that's in there now, especially for me, the inline support for those complex types and those primitive queries. I mean, even above and beyond the JSON support that's in there now, the improved JSON support. Those are far, in a way, the coolest, I think, 2 new features that are in there. Because I can count up, I don't think I can count all the hours that I've spent kind of coming up with workarounds to track and save those data that should just be there. It should just be easy to work with. It should just be simple. A list of ints or a list of dates or something like that. That is so easy to do in .NET, but it's so hard to get it into and out of a relational database. And now it's so much easier and it's so much quicker, and it's just there. You can just do it, and you don't have to worry about all the plumbing to make that work now. So that's it for my contribution for C# Advent this year. As always, I love being a part of this. I think I've been with it since the first year, and every year it keeps getting better and better. And I think it's a fantastic opportunity to share with you a little bit of .NET knowledge and some of the new cool stuff that's out there. So make sure you go out there and you support all the other bloggers and participants for the C# Advent this year, and take a look at the links and give them all your support. And I thank you. If you have any questions, feel free to reach out to me. My website. The best way to get a hold of me nowadays is LinkedIn. I've kind of hit and miss on Twitter and some of the other social media. I've kind of given up on a lot of that stuff nowadays. So if you want to connect with me, you can connect with me on LinkedIn or check out my blog, my website there. And thank you.